Today in class we focused on geometric figures, dilations, and scale factors. And our problem 1 focuses on the scale factor. It tells us that this particular shape, we need to find the new dimensions given the scale factor of 3. And basically that means that we take every value that's given and the new prime factor, the new prime factors or values for our image would be the current values times the factor. So for CA would be the distance between C and A. On our pre-image it's 5. We multiply that times our scale factor of 3 would be 5 times 3 is 15. So on our image CA prime, that would equal 15. Then we look at AT. Our current value on our pre-image is 8. We multiply 8 times our factor of 3. Gives us 24. So our image, AT prime, would be 24. And then again, CT is on our pre-image 12. We multiply our 12 times our scale factor of 3. That would increase the length on our CT prime to 36. As we discussed in class, if you have a scale factor that is greater than 1, it's going to cause your image to get larger, which is why we noticed the values on problem 1 got larger than the pre-image values. And for problem 2, since we have a fraction that is less than 1, all of your scale factors should be less than the pre-image values given. Problem number 4 says to dilate each figure by the given scale factor. Well, in order for us to dilate each figure, we need to know the coordinate pairs for each of our current pre-image points. So I'm going to label them A, B, C. A is at -3, +4. B is at -3, -2. C is at 0, -2. And now we want to figure out our scale factor, our image, which is going to be our A prime, our B prime, and our C prime, based on our scale factor of 1/2. And again, just as we talked about a moment ago, when we have a scale factor that's less than 1, it's going to cause our image to shrink. So we should know right away in our head that we should end up with an image that is smaller than our current pre-image. And I need to figure out what my ordered pairs will be for my image. And in order to do that, I need to take every x and y value and multiply them by 1/2. So, -3 times 1/2 would be -3/2. 4 times 1/2 would be 2. Again, -3 times 1/2 is -3/2. -2 times 1/2 would be -1. 0 times 1/2 is still going to be 0. And -2 times 1/2 would still be -1. And so now I want to plot these new points for my image onto my graph. So my A prime is -3/2 or -1.5 up 2. That is A prime. My B prime is -3/2, -1. My C prime is 0, -1. And now that I have my 3 points for my image, simply connect the dots. And that gives me my image that is a 1/2 scale factor dilation of my pre-image ABC. On the back side, it says to determine the the scale factor for each dilation. And again, we need to find a coordinate pair so that we can use that to determine our scale factor. At some point, you will want to be able to determine whether or not there is a scale factor for the dilation. But we haven't gotten to that point yet. Right now, I'm just going to tell you that there is a scale factor for this dilation and ask you to find it. And so we're going to find a set of ordered pairs, and since A and C up here do not appear to be on a specific line, but B does, I'm going to use that value because it's on my y-axis. So it has a left to right shift of 0 and a y value of looks like negative 1/2. Negative 1.5, which I'm going to call negative 3/2. That was my B prime. Now for my pre-image, 1, 2, 3, 4, 5, 6. So that's also on the y-axis, 0, 6. Negative 6. And now in order to find my scale factor, I'm simply going to take my B prime value, one of the two values, either x or y, and divide it by my pre-image value, either x or y. Again, I have to be consistent. If I use x, I divide by x, which isn't going to help me much because 0 divided by 0 is not going to tell me anything. So I can't use 0 when it's an option. I'll have to use negative 3/2 divided by 6. And so we would end up with negative 3/2 divided by 6/1, which is the same thing, negative 6. Don't forget your negative signs. 3/2 times negative 1/6, because we keep it, we change it, we flip it. Negative 3 times negative 1 would be positive 3. 6 times 2 is 12. This would simplify. 3 goes into 3 one time. 3 goes into 12 4 times. And so my scale factor would be 1/4. Well, now we can look at 1/4 and ask ourselves, does a scale factor of 1/4 cause my pre-image to shrink? Yes, it does. Any scale factor less than 1 will cause my pre-image to shrink. And my pre-image was larger and it shrunk. So a 1/4 scale factor would seem appropriate for problem number 7, the triangle given. Problem number 9, we focus predominantly on scale factors in class, but I wanted to give you an alternative that is consistent with what we've been learning in class as well. And we've done a lot with the proportions, and since our angles tell us that these triangles are proportional to each other, I can look at my two sides that are equivalent to each other and set up a ratio. So 2 is to 3 as x is to 12. And I can say this because 2 is in the same position as 3. X is in the same position as 12. And now we set up a proportion in which we can cross multiply. So 3 times x is 3x equals 12 times 2 is 24. Divide both sides by 3 and x equals 8. And you'll probably find that to be the quickest method to solving these types of problems.